Hello. In this video, we're going to solve a problem from algebra. This is a very hard problem, and you need to have a good understanding of algebra, polynomials, and binomials to solve this problem. Let me explain in detail and see how we can solve this problem. In the equation above, a, b, c, and d are constants. If the equation has roots -1, -3, and 5, which of the following is a factor of ax power 3 plus bx square plus cx plus t. To solve this problem, first we need to understand this is called a polynomial, and when you have just two terms, each one is called a term, then it's called a binomial. So when you look at this polynomial, it is called a third degree polynomial because it has the maximum power it has is 3. So when you divide a third degree polynomial with a binomial, you will get a coefficient which is of second degree polynomial, and you will have a remainder. So to explain in simple terms, if you have 15 and 3, you divide that, you will have a quotient 5, and then you have a remainder in this case which is 0. So when the remainder is 0, then you consider 3 as a factor. So similarly, when you divide this polynomial, you can call that p of x equals ax cubed plus bx square plus cx plus t. When you divide this by one of the binomial, you will get something like this. This is 3 times 5. So this is the divider, and this is the divisor, and this is the quotient. So similarly, when you divide this, let's say we'll divide it by x minus 1. In that case, you will have a binomial. We can call that as a of x. So you will get a binomial a of x times x minus 1 plus some remainder r. So that will be equal to p of x. So similarly, when we do it for x plus 1, you will get p of x equal, this time it will be a different binomial. So we'll call that as b of x times x plus 1 plus r. The remainder can be different. So here you will have r1, here we'll have it as r2. And then p of x, when you divide it by x minus 3, you will get some other polynomial with second degree, and then times x minus 3 plus some remainder r3. Last, when you divide it by x plus 5, you will get d of x times x plus 5 plus remainder r4. So I'm just writing this in terms of divisor times quotient plus remainder. I'm writing it in that format. So now what they're asking is which one of this is a factor. So for this to be a factor, if x minus 1 should be a factor, or x plus 1 or x minus 3 or x plus 5, we want this r1 to be 0. When the remainder is 0, that means this is a factor. So in this case, what is the value of r1? r1 equals, you just take it to the left hand side and you'll have a negative value. But we want this to be 0 means this whole thing should be 0. So when will this be equal to 0? When p of x equals 0, and this also will become 0 if this entire value is 0. So when will p of x be 0? In when x is minus 1, minus 3 or 5. So if we use x as minus 1, in this case, this will become minus 1, minus 1. This will be minus 2. Sum a of x times minus 2 plus r1. And we don't know if this will be 0. This is some polynomial times minus 2. So r1 cannot be 0. Now let's put minus 1 in this equation. Minus 1 plus 1, this will be 0. That means this entire thing is 0. And now the remainder r2 equals 0. So that means x plus 1 is a factor. So this is a possible answer. Now let's try to put minus 1 here. This will become minus 4. Again, it won't be, r3 won't be 0. And you put minus 1 here, it will be 4. So this won't be 0. Similarly, you try minus 3 here. Obviously, minus 3 minus 1 will be minus 4. Here, minus 3 plus 1 will be minus 2. Here, minus 3 will be minus 6. And minus 3 plus 5 will be 2. So when it's minus 3, none of these will make r1, r2, r3 or r4 0. And when we put 5, it's a similar case. 5 minus 1 is 4. 5 plus 1 is 6. And 5 minus 3 is 2. And 5 plus 5 is 10. In all the cases, minus 1, minus 3, 5, and then if you substitute in x minus 1, x plus 1, x minus 3, or x plus 5, the R1, R2, R3, R4 value never becomes 0 except one case when it is minus 1 and x plus 1, then we have R2 as 0. So definitely x plus 1 is a factor of this one, and that's what they're asking, which of the following is a factor of ax cubed plus bx squared plus cx plus d. So the correct answer is x plus 1. So this is a very hard problem, and there is no guesses or anything like that. You need to understand the concept behind polynomial and binomial and division among that. So learn about that in algebra, and this is one of the key concepts, and there will be a lot of questions related to that. That's how we solve this problem. See you in the next video. Bye.